Okay, so first word, English is not my native language, so please don't drop me rocks. I'm already almost a bit drunk, so just drop full bottle of beers, please. That's all. So this talk is combining Syscall proxying, various functionalities, kernel patching, exploit writing with this kind of stuff. I hope you will enjoy. So let's start. So I'm CSK from Uberworld Security, that's a little group with friends. I'm working for a security auditor and researcher for Dreamlight Technology AG, which is in Switzerland. I'm much more specialized in telco auditing, but sometimes I play with computer also, so we'll see the result. So here is our agenda. Some definitions, introduction about Syscall proxying, how to use Syscall proxying for different kind of application, bad or good. The case of exploit writing, which is, I think, interesting us at the moment. How to write local tools for remote fun with the library, Syscall proxy library, and how to play a bit further, like making kind of rootkits with this technique. And after, just a little conclusion, and if I can answer to some questions. Just for the question, please ask for a microphone, else it will not be recorded and nobody will hear it. So just ask. Let's start. So, already what is Syscall proxying? A little introduction. That's not really new stuff. Since 2002, Maximiliano Cáceres from CoreSDI use that for impact. You maybe all know the product. Or just, how many people already know about Syscall proxying here? Nice. Okay, cool. Not so much, but that's old stuff. Yeah. So that's used by the hacker community since years for cool exploits and direct access to the kernel in remote, for sure. So it's used in a lot of automated pest tests or auditing tools like Canva, like Impact. And it's used as kind of super internal procedure call in QNX operating system to share this kind of Syscall between systems. That's really, really cool stuff. Just a little comeback about what is Syscall. I mean, everybody know what is a Syscall. That's just kind of kernel trap used by user on program to access kernel functions. It's well known by shellcode writers and also guys who play with this kind of stuff. So most of all unis use Syscalls, direct, transparent access to Syscalls. And you have different way with Win32 or iOS, which are not transparent Syscall operating system, but it's still possible with kind of well-known Win32 shellcode writing. But that's not the purpose of the talk today. Oh. Don't lose, guys, please. Never lose about a drunk guy. That's not good. I'm just kidding. Oh. So, here start our real stuff. So the basics of Syscall proxying is you can access remotely to this kind of interface to the kernel. The goal is preparing locally your code, you execute it remotely, you get the result, I mean the stacked resultant, and you interpret it locally. From my point of view, the interest from my techniques I use is that's memory resident. We will see later about that. That's providing you a real remote interface. And a lot of things are possible, but a lot of things are possible because that's kind of universal usage you can do with that. The problem, yeah, you can't. The code is not made for fork to execute fork syscall, but you can do kind of stuff like group queue made for rexec. But I don't play with fork actually, I just play with my library and other stuff, but it can be implemented. And yeah, I already said that for Win32 platform, for Cisco iOS, you have to deal in a different way. So how using this kind of applications? So from the good side, what can be interesting with Syscall proxying is all these kind of legitimate Syscall proxy servers for patching your kernel or your stuff remotely for minor upgrade, remote debugging your programs with this kind of transparent access to the kernel syscalls. You can use it as QNX do as remote IPC, and yeah, you just have to be creative because that's a really powerful interface to the kernel you can have remotely. From our side, the most interesting, I think, you can write really evolved exploit, making a lot of things in the same time. We'll see later about that. You can write interesting backdoors, rootkits using this stuff. I mean, always remotely, backdooring processes, backdooring kernel remotely, like you want. And I also say that Attack Framework already use Syscall proxy agents for their work, and some guys are working with swarms and play with Syscall proxy in the same way. Don't lose Mark, please. So, why it can be so useful for exploit writer? You can use it for multi-stage exploit, doing a lot of stuff in the same time. You can use that for all your scalable tool you want, because that's really modular. I mean, all your code is local. You play with your local code, and all the syscalls are executed remotely. It's useful in frameworks because of the privilege escalation you can do, exploiting in the same time, attacking, covering, backdooring, yeah, all in one exploit. You can do that. That's pretty useful. And yeah, you can use already existing Syscall proxy server as kind of transparent op station, op with an E. I love op station like that, during your attack discovery process. I mean, using the Syscall proxy to go in another part of private networks or else. That's totally transparent because you can change Syscall proxy like you want to go to your target. So, more in depth, you have to locally preparing your stack. I mean, packing all the registers, the things you need to execute remotely. You send it to your shellcode, the shellcode executes it, and you get the resultant stack, and you do your local interpretation, and you loop in that. So you can execute how many syscalls you want with the same shellcode, so pretty useful. That's really universal interface to Unix systems, because you just have to write your code locally with how many syscalls you want, read, write, what you want, and it's all executed by one shellcode. My test shellcode are around 150 bytes, so that's almost usable for a lot of exploits. But for that, yeah, you need kind of library. We'll talk just now about that. So, what we really need to make the work easier. So we have already shellcodes. I wrote Linux shellcode, BSD shellcode for these techniques with connect byte, find sock, IDD page for kernel patching, stuff like that. So we already have all we need for that. We have to rewrite our tools locally to be used remotely. And we really, I feel really the need of using kind of easy API for writing my tools. So I rewrote a kind of ultra light glibc for Syscall proxying usage. I mean, just a basic libc you can use. Instead of read, you have sp read, things like that. So all the normal calls are just replaced by sp before, and you can use that as a normal open, normal read, normal exit, normal ptrace, what you want, not a problem. You can just make a grep and replace your stuff in your programs, it will work. So basically you just have to initialize the library, because like I said, I did the code for BSD also. You get the stack base address to calculate your local variable, which would be stored remotely. So you need this address to calculate the stuff. And also IDT, which is interruption description table for kernel patching, remote kernel patching. That actually is the stuff. So what can we write with this kind of library? So during audit or during, I don't know, your night work, sometimes you wonder about if the shell you access is monitored or else. With Syscall proxying, that's really not a problem because your shell is locally written and all the Syscall you need are executed remotely. So yeah, I mean, I don't know any OS which is trying to log all the Syscall attempts. That's useful. You can integrate what you want, kind of importing, exporting files functions. I did it, that's really working well because you can open locally a file, you can open remotely another file, and you can read and write through the socket. So yeah, you can copy files with the shell. That's useful. And always, the thing I try to is keeping in mind less possible code in the ONNET box. Really, less possible. I mean, all your tools are on your local box, and you don't take care about what you can let us binary for reverse engineering for what you want after the ONNET. All is memory resident, and all your tools are on your box and not in the ONNET box. So the tested code was UWSP mini shell 2. That's the second version with this kind of importing, exporting functionalities. The first one is public on uberworld.org website. So next we need kind of network application. So I already written most of network syscalls in my library to play with network tools remotely and use it for trusted host relationship attacks or else. So like the shell, every tools are executed remotely. It makes the attack difficult to trace because you don't let any binary on the box. So I did kind of simple TCP connect scanner, which is executed locally. All the Syscall are remotely executed, and you scan the box you want. So you can do more, but that's already working well. That's cool, like that. Oh, so here starts, I think, interesting things. And that's about how I can remotely infect a process. How can I inject a code? you can do a lot of things with that. It depends on which kind of technique you use. You can backdoor process like SSHD or what you want remotely. If you can execute a Syscall proxy shellcode through any vulnerability or else, and if you have enough privileges to ptrace or to make other stuff to the target process, you can inject the code, you can make static patching also, you can do more or less what you want. So yeah, useful for worm writing, for stealth backdoor. We will see just later how to play with that. So first technique, the amazing thing is the Linux kernel, when you execute a binary, the .text section where the code is stored is not writable. But when it's charged in the kernel memory, you still have access to the PID through /proc PID exe, and this .text section is writable this time. I really don't know why, but yeah, you can write what you want because it's not used anymore by the kernel. The kernel take all the code in this section, put it in memory, and let it free for you. So you can inject code into it, your Parasite, what you want. And for executing your Parasite, you have to hijack kind of code entries. Like for read, for example, that was my test with SSHD. Each read are redirected to my Parasite. The Parasite is executed, and after it returns in the normal read function. So you can, for example, detect your password or login stuff in the read and open new kind of backdoor you want. It's resident in SSH, so that's cool. But yeah, because that's a GOT technique, it's only work with dynamically linked binary, for sure. And the cool stuff, it don't change the size in the process. So yeah, that's more or less stealth. The only way to spot it is using tools like memfetch or else to copy the running process and look around. So the only problem is, yeah, you are really limited by the .text size, because on my experimentation, that's around 200 to 300 bytes only. So for a basic hijacking Parasite, you can do it, but that's not really usable. The test code I publicly released is UWSP inject process, which is available on my website. But that's not really the best you can do with that. The second technique is much more usable. So the goal is inserting as many as code as you want in the remote process, using two-stage injection with kind of mmap code. So you ptrace the process remotely, you inject your mmap code into the process, you execute it, and it creates a memory zone like the normal mmap do. You can, with this zone, inject your Parasite in. You wake up your Parasite with signal alarm code, which is really basic. You don't need any GOT hijacking or else. The code is just waking himself every minute you want, no problem. And it works with static linked binary, dynamically linked binary as you want. Like init, for example. We'll see later about init. And yeah, the bad thing is it's modifying the process size in memory, but you can spot it, I think. Yeah, that was not my way. And yeah, the good stuff is you're really not limited in which size is your Parasite. You can inject what you want. I try with 2 megabytes or a bit more kind of Parasite. It was working well, so yeah, you can inject what you want, even big code or okay. So the public code was mmap inject. That's also available on yourworld.org. The code is really working well, so just try it and give me feedbacks if you find something strange. The test code is with connect back shellcode executed every minute. It tries to connect to you and provide you shell access. So that was the work, more or less. But I think most of us are really lazy guys, and I really hate rewriting code with my own library. Really lazy guy. And so how can I use my old tools like nmap, telnet, SSH, what you want? The only stuff possible is LDpreload. So what I did is uberwall's cisco exec. That's a LDpreload wrapper for all the Syscall I written in my library. It's still in development, but really usable. I can use that with SSH. Telnet, I tried with nmap, stuff like that. The only problem you have to deal with is you really can't detect automatically which kind of Syscall you have to execute locally and which you have to execute remotely. I mean, you have a tool written with read and write. It's read file, it's read sockets. So how you can deal between, okay, this one I have to execute it locally, and the other one you have to execute it remotely. So I have defines, and I just read the code of the tool I want to use, and I check the defines, and if that's okay, I test it, and most of the time it works, so nice. But if somebody knows a technique to detect automatically which kind of Syscall have to be used, I will be pleased to offer him a beer. So, let's see. Oh yeah, my beer. I think I'm too quick, but that's not a problem. We'll talk. I can talk a lot with beers. So, with this library, shellcodes, application, what can we do a bit further? How we can really play with this kind of exploit to do a lot of things in the same time, and how can we rootkit a box or cover your traces in the same time you're exploiting the box. That was the tricks with initfucker. Sorry for the name, I just like these kind of stupid names. So, basically, what I was playing with is combining this Syscall proxy stuff with the nmap inject stuff and playing around, and I was searching how I can play with a really non-traceable process and how I can hide my stuff really deep in the system. So the trick is you exploit a vulnerability using a Syscall proxy shellcode. Because you have a direct access to the Syscall, you can execute your local root exploit through schizo exec, for example. You get root and you patch remotely the kernel using the well-known IDT tricks presented in frac 68, if I remember well. So you can patch the kernel directly through /dev-kmm with ASP-LC, read, write, and do what you want to the kernel remotely. I really don't understand any word of German, so maybe you have to drink a bit. Yeah. I played with Linux 2.4, 2.6, 2.6.10. It was working. Yeah, surely. And you have this kind of VA pitch, horrible stuff, and other, but that was not the purpose of the talk. I mean, I was playing with the kernel, I was looking how you can do with that. If you can't patch the kernel, try another way. You have direct access to Syscall, so you don't care really about which technique you use, which kind of stuff you use. I was just wanting to demonstrate what we can do with kind of normal non-JSX patch kernel or else. But yeah, find your own way, be creative, I think. That's the best way. So, the basic concept of my lightweight rootkit. You use a vulnerability to direct rootkit the remote host during the exploitation process, all is one time. It's really modular because all your tools, all the different stuff you need are locally stored. So during the exploitation process, if you miss something, oh, I didn't play with that, I didn't cover my traces, okay, just launch your client, connect to the Parasite, and hide your traces. Yeah, that's modular. If 1 month after you think about, oh, I can do kind of cool thing with that, but I missed something, okay, just write the client and execute it through the Parasite. Always the same mentality, really least code possible on the on-end box, yeah, for anti-forensic purposes, for sure, and for the scalability of your kit during the on-edge itself. And what I was playing, I was memory resident, so I didn't let any binary to play for the admin after. So you have a vulnerability working. Here you have kind of evil server with a really bad vulnerability, stupid buffer overflow 1. You write a little exploit to inject the Syscall code. Here I use a find sock IDT patch shellcode for many reasons. I do the privilege escalation if I need it. I remotely patch the kernel to be able to ptrace in it. That's really reliable with 2.4, 2.6 kernel, because if you look at ptrace ATH part of the kernel code, you have this compare assembly code, which is just looking at your PID. If your PID is 1, it don't let you ptracing anymore the process. So you just have to change this 1 in 0. So you're able to ptrace in it and to inject what you want into. So I use the mmap technique to inject. Here is the 800 bytes Parasite. So it works. And after I repatch again the kernel, putting 1 instead of the 0 to stay in a normal, to keep the kernel normal and to don't let the administrator try to ptrace in it to see, oh yeah, somebody rootkitted my box. So I repatch it, and all is well, all is everything back, and that's perfect. So I play a lot with Parasite. That's a really interesting field. You have a lot of problem writing this kind of worm or viruses, parasites, payload, what you want, how you want to name it. So mine is a mix between assembly and C code. Because first I was writing only pure assembly Parasite, and that was really horrible to add cool features or what I want. I was obligated to look again at my whole code and do my stuff. So I rewrited it with C code, and the problem is I have to totally keep the independence from the compilation platform. So all the Syscall are totally manually done. You have a lot of defines because the sockets, the Syscall name under BSD, under Linux are not the same. I'm run mostly BSD. I attack mostly Linux systems. And I have to keep it really independent of my compilation platform. And yeah, all have to be made for the Parasite to fit really with the target architecture. I will show you just after how it's written my Parasite. And yeah, for sure, it integrates a Syscall proxy server for later usage. So the Parasite is, when you inject your shellcode, after you ptrace, you'll be able to ptrace in it, you inject your mmap shellcode into init. The first time init, the mmap shellcode return, you have a signal alarm code, which is just launching for the first time the Parasite. You loop in a non-blocking read during 5 seconds, expecting kind of magic ICMP packet to wake up the Parasite. If it receives the packet, the Parasite fork and connect back to the source of the ICMP packet and use as port the sequence number. That's really dynamic. I mean, you can use which port you want. It works perfectly. And the Parasite is waking up every 60 seconds with another signal alarm code. The strange thing we found with Dash, playing with that, is the Parasite is multi-users. So you can have different guys using the same Parasite because it's forking, and yeah, we was two playing. You're connected? Yeah, I am. But why I don't see you? I don't know. Oh, we are two on the box, two running the same Parasite. Cool, nice. That was was funny. Just a little explanation why non-blocking read init is only the signal, the alarm signal. And when you have a read, you have the signal just before. The read is dropped, but after the read is relaunched, so it's blocking init. Yeah, I don't want to block init, else I'm fucked and the system go wrong. So that's why I use this kind of non-blocking read. The signal sent by init is air restart sys, something you normally don't have to see as user. Yeah. And yeah, that was a big pain to debug this, and finally I take my non-blocking stuff and it was working, so I didn't care about the rest. So the little client I wrote is kind of tunnel between the Parasite and itself to provide locally a Syscall proxy access to your tools, all your tools you read. And if you just have to, you use your tool locally, you connect to your local Syscall proxy, we'll see it during the demo. That's it when you want to close. The client just sends an exit to the Syscall proxy code in the Parasite, and the Parasite end, and all stay in the same place. So that was the tricks. I really don't know if I was so fast. What hour is it? 6:30. I'm fucking. Yeah, I have a fucking problem, I think, so no problem. I will drink beers. And somebody have a little joke to tell us, or no? So, okay, little demo. I think now I'm obliged to show you a bit of the code. So, as I told you, the Parasite is, I have to define a lot of stuff locally. I have to execute all my syscalls like that, because I can't call the libc or else. Yeah, that's inline assembly, that's horrible, but there is no other way. I will just explain why after. So you have the Syscall proxy in the Parasite, and you have your normal C code. I'm obliged to play like that with the, because I can't use the structure, I can't call stuff in the libc or else, though. That's really a pain to write. And so you can see at the end, Parasite end, and at start, Parasite start. And that's why I'm obliged to use inline assembly, because else, if I write another .s file, I can't pack it and make a bit binary to inject into init. So that was my way. Maybe there is another way. I think that's already better than writing a full assembly Parasite. Really more reliable. I'm at the moment playing with compression, steganographic covered channels and stuff like that. So the big problem with Syscall proxying is packing your stack, sending the stack, receiving it, consume a lot of bandwidth. That's a lot of data, and you have to compress it in a better way. You have a lot of zero from the memory, so you can do it in a smarter way, but that was my way at the moment. So the library, what I did actually is those shellcodes, those syscalls. So not really a lot, but that's already fine to write your tools. I will do the demo. I think it will be better to let you understand the stuff. So here I have a really evil bad server with a stupid vulnerability. I'm in. Ooh. I just launched my vulnerability, which is stupid. Fuck you, Linux. Just a basic buffer overflow, nothing more. That was just for the demonstration code. The exploit is written in this way. Oh, man. So you have your Syscall proxy find sock edt patched shellcode. You have your basic stuff for exploiting the stuff. Oops. And here, stop the normal exploit stuff. And so you get ESP, you get IDT, you patch your kernel, you inject your Parasite, and you repatch the kernel another time. So let's run this stupid vulnerability. Ooh, bad. Never do it at home, kids. That's an evil server. So it's running on port 5000, okay? Let's run. So I patch the kernel. I detect 3 types of different GCC, because you know this kind of, I don't know what is the name, Debian, that's it? The Debian guys are really weird. They like to patch their GCC, so I had to find new pattern in the kernel to patch the stuff I need. So I'm detecting different GCC version. I detected that the 2.4 kernel, if I look if that's right, yeah, really bad. I will try it with 2.6.14 maybe. We'll see. So actually, I injected a 800 bytes long Parasite into init. I have just a local little tool. Op. I will rename it in Umpa. The kernel is now patched to be able to see what init is doing in real life. Yeah, behind the behind the ptracing stuff. So you have init right working normally. You can see it's not blocking. I have my client. You can put, yeah, okay, echo request or what you want. I wanted to connect back to port 9000, for example, and I send my magic ICMP packets. So I have to wait. You can see during this time the Parasite was making the non-blocked read and waiting for your magic packet. So we have to wait 1 minute. That's a good thing. So anybody have something to tell us or any question during this time? Nobody really? Yeah?
Okay, I'm wondering, so you're transferring the argument from the Syscall to the target?
Yep.
The return things back?
Yep.
So is this encrypted, or are you planning to I think otherwise one could write an IDS signature?
Actually, that's a work, because that's why I rewrite it totally, the Parasite in C code, to implement this kind of stuff easily. And I'm more or less working on my main problem, which is the compression of the stream, but you can easily implement basic or more evolved encryption. And my way was more working with active steganographic cover channel with a fake web browser, which is making a lot of queries to have a stream and to steganography your usable stream into. That was my way, but because I was thinking, okay, if I have to implement kind of encryption routine, it will take a lot of place. So I don't know. Just XORing the stream is really not interesting. And I don't know. I think AES is really... Yeah, already you have kind of secret. The ICMP ID is used as secret. So each packet I send, each ICMP packet I send are not opening the backdoor. So maybe I can...
Yeah, exactly. That's your sort of authentication which you have. But you can basically use the same utilization to provide a simple implementation for it as well, which would make fingerprinting it with an IDS pretty much unfeasible. So
sure, but yeah, when you follow the we will just see later. When you follow the Syscall proxying work, you don't have any real pattern. That's always changing because of the stack, and you don't have really. That's not really easy to make a pattern matching on it. You can do a pattern matching on the shellcode for sure. So maybe I have to write more on the shellcode, but I have to keep it teeny. That's why I didn't integrate it. Oh, just you see the normal ICMP are not opening the backdoor. So yeah, the key is in the IP ID, ICMP IP ID. So, but yeah, for sure we can work around and we can integrate stuff in the Parasite. That's why really I wanted to rewrite it in C code. The protocol is really basic. You pack your stack, you send a first packet with the size of the stack you will send to it, to the shellcode. You send the stack packed, and after it reply you with the same size as your stack, just copying the stack and give it to you after. So nothing really complicated. I mean, these techniques are already known since years, but I never saw anyone publicly showing the stuff. So now I have my tunnel connected to my Parasite, and what I want to use is my different tools So I have the client of the rootkit, I have the rootkit, and I have my tools. I want to connect to my client and use this tunnel. You can encrypt or what you want, and use that as media to give order to your Parasite with Syscalls. So that's my basic shell. So the tip is a bind shellcode. I connect locally. So my client gives me what he knows about the stack address of the remote unit. And I can do what I want. All is executed locally. The Syscall is executed remotely through my tunnel. So that's it. I can look at what is this test to file. That only Syscall, all is written locally. I can get the file. No, which one it was? Oh, test 2. I have the file. Where did I launch these stupid tools? Yeah, no. Here is my file. That's the same. I can also put files. Okay, nice. Fuck you. Okay, demo effect, cool. But yeah, basically that was the tricks, and I will just hide this. It worked, and no, we already spotted with Dash a kind of problem with the library, and we are rewriting the right version. So yeah, basically that was the demo, and so you can see, you can eject your Parasite, you can play with, and we will see further in the C code to add real stuff, for sure. So, what can we do a bit further, excepting writing not proof of concept code, but much more real stuff for process hiding or else? The interesting way for me is investigate about the legitimate server side. I mean, using Syscall proxying for patching my stuff remotely, administrating a lot of box in the same time, things like that. All these kind of worm are also really interesting since I'm playing with Parasite. I love that, and I think I will write kind of good worm to patch my server directly without having any problem with Syscall proxying. The OS development is really great way for this kind of techniques. And yeah, please be creative. You're hackers, you have to be creative, guys. So just play with that. That was just proof of concept, but I think it can give ideas to guys to make cool or bad stuff. That's it. Thanks, so see you at bar. I'm already there.